Hello and welcome to part 2 of lesson number 7 in Unit 1 Linear Systems in our grade 10 academic math class. This is modeling linear systems of equations. This lesson is all about just setting up word problems by defining your variables. Obviously we're doing linear systems, so there will be 2 of them, and then learning how to take the words and turning them into equations. So we've done the first few here already. We're just going to jump right in with the next one down. That's E. And it says a vending machine contains $27.70 all in quarters and dimes. If there are 199 coins in all, how many of each type are there? Okay, so this question right off the bat, this is like a money question, I guess you would say. We're talking about quarters and dimes, so we're going to let X represent the number of quarters. Number of quarters. And again, we don't have to put a unit on that because we're just talking about the number of something. And let's let Y represent the number of dimes. And like I said in the last, or in the first part of this lesson, you can make this let Q represent the number of quarters, let D represent the number of dimes. It's up to you. I just use X and Y because it's kind of just, I tend to just use X's and Y's, I guess. So a vending machine contains 2770 all in quarters and dimes if there are 199 coins in all. So that's where we're going to start. If we take however many quarters there are and we add it to however many dimes there are, we have 199 coins in general. And I would basically call this like the sort of the number equation, I guess you would say, where we're talking about how many coins there are, just the number of them. Because the second equation, again, typically has to do with how much the money is worth. So if we recall that quarters were the X variable that we defined, their value then would be 0.25 x's, and 0.25 of course representing that 25 cents represents a quarter or is a quarter. And we are going to add that to, and Y is dimes, so that'll be 0.1 or 0.10 Y. And the total value of these coins is going to be 2770. And that is going to be equation number 2. And that's what I would call like the money equation, the one that deals with the cash. So again, these money style questions, there tends to be an equation that deals with how many coins there are, and there tends to be an equation that deals with what is the actual like monetary amount of the coins that you have. And that's when you start to see these guys here, like the 0.25 for quarters and 0.1 for dimes. That's how you work the money ones. And from here we just go on to solve. Okay, F. Jerry invested $10,000 for 1 year, part at 8% per year and the remainder at 10% per year. If the total interest for 1 year was $940, how much was invested at each rate? So we have $10,000 to play with here, and we have a certain amount invested at each of these two percentages. So let's let X represent money invested at 8%. At 8%, and we're going to be measuring that in dollars. And then our second equation is we're going to let Y represent money invested at, I think it was 10%. Yep, 10%. And again, that we're going to be measuring in dollars. These are investment style questions. Similar to the money question above, where we have something that deals with the money, like the amount of money originally, and then something that deals with the percentages. So let's do the sort of monetary one first. So these two sums of money, if we were to add them together, so the amount invested at 8 and the amount invested at 10, if we were to add them together, we would have $10,000. And that's sort of the original, deals with how much is invested sort of holistically or in total. Now our second equation is going to deal with these percentages again. And as you can recall, 8% is actually 8 over 100, which is 0.08 at X. So basically, however much is invested at 8% multiplied by 8%, added to the amount invested at 10%. So 10% is 10 over 100, or 0.1. If you multiply those two things together and then add them, you're going to get the total amount of interest earned. And as I recall, the total amount of interest earned was $940. There you go. And so that is equation number 2. Again, here we've sort of got, if you wanted to break them up, this is sort of the percentage one, and this one here has to do with like the total money being invested. Again, they generally kind of are all set up the same way, just so you can sort of keep it in your head. Use this as a reference for sure. And last but not least, this is a mixture question, and this deals with mixing two amounts of something to end up with a third amount, and each of them has sort of a different price. Let's read the question. The grocer mixes jelly tots worth 45 cents per pound with jelly beans worth 35 cents per pound to make a 70-pound mixture worth 41 cents a pound. How many pounds of each type did he use? So let's get this. Let's let X represent amount of jelly tots used. Tots used, and they told us that the unit of measure is going to be pounds. In the second one, let's let Y represent the amount of jelly beans used, and that is also being measured in pounds. So those units, super important. I know I've said it a lot. I mean it. The units are important. Okay. So similar to the previous two examples, we know that however much of the jelly tots we have added to however much of the jelly beans we have in total comes to 70 pounds. That is our equation number one, and that's sort of like the overall amount. And now we're going to mix in, we're going to do sort of a money one. And the money one is 45 cents for the jelly tots. So let's write out 45 cents times however many pounds of jelly tots we have, added to 35 cents, so 0.35 times however many jelly beans there are, is going to equal, in this case, 41 cents, I think. 41 cents. And this is the part that makes this question unique. It's 41 cents times, we actually know that there are 70 pounds of the mixture at the end. So that's the piece that we add. Previously, we don't have that. You're usually given the amount of tax earned, or you're given the amount of money that the system, the value of the money that the system has. In this case, it doesn't give it to you explicitly, but it does tell you that 41 cents times times the 70 pounds you have at the end, that will give you a number that will finish up this equation. But this is how you write it out. So this whole lesson has been about setting up linear system word problems, how to set variables or define variables, and then how to set up these two equations. As I said, there's lots of things that are in common in each one. The homework that you have to set up is sort of all of these different types. However, when we get to the actual word problems in unit number 8, you'll see that we're only working on 3 varieties. We're working on break-even problems, relative number problems, and everybody's favorite, the age problems. If we have time at the end of the course in Unit 6, when we're working on quadratic word problems, we might sprinkle a few of these in here and there of these other varieties. But for now, just in terms of like assessment and things like that, you really only need to sort of master 3 of them. The relative number problems, the break-even problems, and the age problems, which all 3 of, or 2 of those, all 3 of them were done in the first video. So good luck with the homework. If you have any questions, reach out, email, in class, in person, or via our online discussion, and hopefully I can answer any questions you have. One more lesson to go. We'll see you in lesson number 8.